Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Thank you for coming to this presentation. It's great to see you all. My name is Daffa Fajri Riesaputri. I'm a student from Dian Nuswantoro University, Faculty of Computer Science. It's great for me can take part on iSemantic 2020, even in COVID-19 pandemic conditions. Hopefully, you are all in good health and stay home so that this pandemic can pass soon. Today, we are going to discuss about classification of breast cancer using PNN classifier based on GLCM feature extraction and GMM segmentation. The first time, I will start about my presentation from introduction. Second is about probabilistic neural network. The third is proposed method. The fourth, experimental result, and the last is conclusion. First, I will explain to you about the introduction and why I choose this topic. Breasts are parts of the woman's body that begin to grow during puberty. Before puberty, breasts in both men and women have a similar shape. During puberty, there is a change in the composition of female hormones that cause breasts to grow. Every part of our body is composed of cells. Our cells do not live forever, but instead undergo a process which young cells are born, then age and die. The growth of the body cells and their functions are governed by genes that play a role in ensuring cell information from generation to generation takes place properly. When these genes mutate or grow abnormally, there is a change in the process by which cells that are supposed to die, but they still grow large and multiply uncontrolled. This is where the cancer process is formed. Based on data from the 2018 Global Cancer Observatory from the World Health Organization, the most common cancer case in Indonesia are breast cancer, which is 58,256 cases or 16.7% of the total 34,809 cancer cases. The Ministry of Health of Indonesia states the number of breast cancer in Indonesia reached 42.1 people every 100,000 population. The average death from this cancer reached 17 people every 100 population. This is supported by statistics from the American Cancer Society, which shows that this disease is ranked first with the highest number of cases of all types of malignant tumors worldwide. Conducting early detection of breast cancer is good early prevention, one of them by breast screening or mammograph who can find out whether there is a growing tumor, so that from the result of the examination will be found early diagnosis and treatment. What is mammogram? A mammogram is an X-ray pictures of the breast. And next about the algorithm. The probabilistic neural network is used in this research. Why PNN? PNN is one of the neural network models, which is often used for a classification. The algorithm does not require a large dataset and can overcome a problem that exists in backpropagation. The PNN algorithm is composed of four parts, namely the input layer, the pattern layer, the sum layer, and the last output layer. The PNN is often used to classify because it can map each input pattern to several classifications with a faster process compared to other neural network models. PNN can also map pattern optimally or have a high accuracy value. However, PNN has problems determining the smoothing parameters, which are usually determined by trial error or use-defined. Besides, PNN also combines the Bayes theorem and the Parsons method to estimate the probability density function of a random variable. In contrast to other neural networks, PNN has a high training ability, so that it can produce a great level of accuracy decision-making on classification. This study proposed the PNN method to classify the types of breast cancer. The stages carried out in this research are: first, collecting mammogram as input. The image has dimension of 1024 pixels multiply 1024 pixels, consisting of 3 categories: normal breast, benign breast cancer, and malignant breast cancer. Each category consists of 20 images, so there are a total of 60 images. Then, the entire image is resized to 256 multiply 256 and convert to a grayscale image. The second is applying the median filter. A median filter is used as a first step before the image is further processed. The aim is to reduce noise in the image so that the result of segmentation in the image can be optimized. The third is image segregation using Gaussian mixture model. Fourth, the GLCM used as a feature extraction. And the last, the classification using PNN to get the result. After going through several stages, use 60 images consisting of 3 categories, the classification process carried out using PNN in the image of the entire dataset, where the result of the classification are 100% as shown in table. Based on the classification result presented in table, it appears that the proposed method can work well, even it can be said to be able to classify the image of mammography perfectly. Some research related to the classification of breast cancer has been done before, such as: first, Kanchana and Varalaxmi researching the classification of benign and malignant breast tumor using wavelet based on the threshold method. The dataset used was 25 training data and 17 testing data from MIAS, which produced accuracy value of 92.30%. Second, Khosravanian and Ayat classify breast cancer using the PNN method. The dataset used was 239 cases, consisting of 184 cases, and the result of classification produced an accuracy value of 99.1%. Third, Zhang in the study of breast cancer tumor classification using PSO-PNN algorithm with dataset of 100 samples from the MiniMIAS database. The accuracy value was 98%. And Yaba researched the detection of tumors in the true screening test of mammography. The discrete wavelet transform method was used in this study with a dataset of 50 mammogram images and producing an accuracy value of 80%. The conclusion: this research proposed the PNN method as a classifier to classify 3 image classes, namely normal breast, benign breast cancer, and malignant breast cancer. By using several pre-processing steps such as: first, resize to calculate calculation and equalize size, convert to grayscale to get GLCM feature extractions, third, median filter to eliminate noise, and followed by segmentation operation using GMM and GLCM feature extraction. proved to produce a classification method that can work very well on a small dataset. Classification accuracy reached 100% in all testing data. Thank you very much for your great attention. May all those we have shared be beneficial for all of us. Bye-bye.